All right, all you calc disciples, we're coming at you with some U-Substitution, but before we do, got some stuff to show you. In case you all thought I was a little nutso. Reg, you guys stay here for a second. Reggie's curious. Stay. Stay. Just in case you thought I was all nuts. The duckies are here. They are rocking and rolling. There you go. Just in case you thought I was all a little crazy. We do have the ducks. Reggie's pumped to be a duck dad. Alright, here we go. Let's get after it. A little spice up beginning of your week here, getting into some U-Substitution. Alright, so now, this is going to be a big one here as we move forward. Alright? The U-Substitution. Alright, if this is like the reverse of the chain rule for the derivative. So if you think back, when we had a derivative, we did the power rule first. Hence, for an integral, power rule first. Then we did the chain rule for derivatives. Now for us, U-Substitution for the integrals. Now this is a shortcut for the simplifying, like we talked about with the chain rule. We wouldn't want to distribute 900 times. That's why we had the chain rule, right? So we're still thinking here quantity to an exponent. When I see parentheses, or I see a parenthesis to an exponent, we're thinking U-Substitution. So what we're looking at is we're picking the part that we're going to integrate, and when we take that portion's derivative, it's actually going to be within the problem. Alright, so this one gets a little tricky because we're integrating, yes, but we're also tying in this derivative concept too. So first, the reason we're doing this, we're going to find a portion that U is going to replace. Alright, so we're going to have U and du. Du is the derivative of that portion. So what we end up doing is we're taking the problem in terms of x, and then we make it in terms of U. So instead of having x and dx, it will be U and du. Alright, U-Substitution. Alright. So for us, as we go forward, we're going to start off slow here at first, right? The value of du. So sometimes we're going to have u and du. Everything's going to be match up. Everything's going to be hunky-dory. Everything's going to be great. But as we move forward, not always going to match up. So if du is too big, meaning that the number or the value we're getting is larger than what's in the problem, we're going to have to compensate with division. If it's too small, we're going to have to compensate in the problem with multiplication. Alright? So keep this in mind as we go forward. Alright? For now, everything's going to match. Not going to be the case as we keep going. So first, what we want to do, we want to find out what u is. That's the most important part. That's the quantity to an exponent. That's the number or the values under the radical. Alright? We're going to replace, once we know what u is, we're then going to replace the dx part with du. So it's all in terms of u. We're going to integrate with that power rule, and then we're going to put u back in at the end. Alright, so here we go. Let's start off nice and slow. So for example here, no shot we're distributing this out 10 times. We're integrating. There's nothing to simplify here. Nothing to simplify, right? We need a u substitution here, because it's a quantity to an exponent with integration. So u, in this case, is always going to be the quantity. So for us, u, all right, u is the x minus 4. That's what's in the parenthesis. Du, its derivative. Now this is where people get all fugazi. We go deriving while we're integrating, so you have to remember the other concept. If we took the derivative of this, derivative of x is 1, derivative of a constant 0, so its derivative is 1. So we have u, and du is that imaginary 1 that's really in front of this, so everything matches up in here. So what this turns into is u to the 10th power du. Because everything matches up, du replaces dx. Now this we can integrate. Power rule. Add 1, put it over to the new. Becomes u to the 11th over 11. And then in the final part, put u back into the problem. We get x minus 4 to the 11th over 11. Don't forget Carlos. We need him. All right. Here we go. Shall we? Same thing. We cannot easily simplify this. There's a quantity to an exponent. U-substitution. U is always the quantity. So u is our 5x squared. Du, when we take the derivative of this, is actually 10x. So lo and behold again, everything matches. U, 5x squared minus 3. Its derivative is 10x. It all matches up. So we can replace all this, u to the 6th power du. When we integrate, add 1, put it over to new, not forgetting Carlos. Make sure we replace u again. Right, I hope you're all following me right now. Now, as we go through this, some of you are going to get really good at this. You're not going to have to do the u and the du. You're just going to start to see it. You're just going to start to see it. You're going to recognize, well, this is the derivative of this. I need a u substitution. And some of you will be able to just add 1, put it over to new. You'll start to get really good at it. All right? Oh my God, Coach Dal. There's a radical. Don't worry about it, broskies. We're going to rewrite it. We don't like radicals. We don't like fractions. Let's rewrite it. I have a quantity to an exponent. U-substitution. Again, some of you might see it. Well, the derivative of this is this. So it's all going to work out. Just add 1, put it over to new. Right? So here we go. U. Bear with me here. Well, u is the x squared minus 5. Du is 2x. Everything matches up. It's all hunky-dory. So we could just make it u to the half du. When we integrate, add 1, put it over the new. Make sure you replace u at the end. Alright, now you have to bear with me. I had some technical difficulties. Alright, we would not want to leave this how it is here. Alright, we want to write this with no fractions, and we want to write it with no rational exponents. Alright, so when we rewrite this here, and again I had technical difficulties before, so I'm sorry. Alright, we would want to make this, when we multiply, it would really become a 2/3, and this would become the square root of x squared minus 5 cubed. Alright, so I apologize for that, everybody. Here we go. Let's get to the next part here. Just because it's a trig function doesn't change our thought process. The quantity is what we're going to make u. Again, you'll start to notice this is a little different because normally we're used to just like sine of 3x. And we have a constant in front or something like that. Now we have something in the parentheses here. U is the quantity. Some of you can see it. du is already out there. U, du. Everything matches up. We're good. So it just becomes sine of u. Integral of sine is negative cosine of u. We don't have to put it over the imaginary 1, right? Normally we put it over the imaginary 1. We don't have to do that here because we've realized it doesn't affect us. Replace u at the end. So this would be our final answer. Give that a try. Again, because of the forms of technology. I know you're able to pause, rewind, all that, and we'll go to our last example here. Again, we got multiplication going on in here, but we have quantity in here, right? We're thinking U-substitution. So it's a trig function. The quantity is u, x cubed plus 5. Some of you can see it. du is 3x squared. It's already there. So we can replace u and du with sine of u du. Sine integrates to negative cosine. And then we got to replace u at the end. Alright? So now for us, in these previous ones, everything has been great because everything matches up. So what happens if if du does not match up? What do we have to do? That's where we need the adjuster. So we have to make an adjustment. Now the adjuster is that multiplying or dividing thing we talked about in the beginning. So if our number that we get is too big and it doesn't match what else is in there, we're going to divide. If the number we get is too small and it doesn't match, we're going to multiply. So here we go. We got a trig function. This is u, right? Well, when we get du here, all right, and here's what happens, which is a little different. U is the 3x squared. Du is 6x. We need it to be an x, though. So in order for our du to match what's here, if we divide this by 6, that will make it match. Dividing by 6 or multiplying by the 1/6. If I had to divide by a 4, we would make it a 1/4. Divide by a 7, make it a 1/7. All right, I hope everybody's following me. Oops, sorry. I hope everyone's following me right now. All right. So we want it to match. If I divide by 6, it matches. We're good. That allows me to replace everything inside. All right. So this cosine of 3x squared becomes cosine of u. There's my adjuster. So it matched out here. And then we integrate as usual. Cosine of u becomes sine of u. The 1/6 stays. And then replace u at the end. Hope you're all with me. Here we go. Let's look at another. Same thing. I'm throwing trig functions at you, but it's the same for everything. Quantity, u, du. Here we go. U is the 5x squared minus 3. Du is 10x. We need it to be a 20x though, so it matches. So if I multiply the 10 by 2, it matches up. So 2 is my adjuster. Alright, because we have to multiply this to get that. This can then be replaced. So now we have sine of u integrates to negative cosine u. Again, don't be forgetting Carlos in any of these. We can really just make that negative 2 cosine u and then replace u at the end. And here we go, right? Like I said, quantity, right? Doesn't always have to be trig function. We have a quantity to the exponent. We're thinking U-substitution. U is 5x plus 7. Du is going to be 5. We need it to be the imaginary 1 though, right? Because there's an imaginary 1 in the front. So our adjuster, in order for us to match that 1 that's in the front, if we divide du by 5, we get the 1. Hence, the adjuster is 1/5. So u, du, we need it to be a 1. That's where the 1/5 comes in. Now we can replace everything else and integrate as usual. U to the 20th becomes that. Leaving the 1/5 out there. Replace u. Simplify that all the way. As always, email me. Find me. Alright, reach out to me if you're having trouble with this. Alright, you know I'm here to help you, and I hope you all had a great weekend, alright? We will be in touch.